Good morning to all. Welcome to our channel Info Physics. Hi students, last video we had discussed about properties of addition and power of I. Now in this video we are going to discuss about multiplication, properties of multiplication, division and complex conjugates. Multiplication. The product of two complex numbers, that is z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. So substituting these values of z1 into z2, okay, is equal to x1 plus iy1 into x2 plus iy2. So we can get x1, x2 minus y1, y2 and plus I into x1, y2 minus x2 into y. So which is equal to x1, x2 minus y1, y2, comma x1, y2 minus x2, y1. Then the properties of multiplication. Multiplication is associative. That is z1 into z2 into z3 is which is equal to z1 z2 into z3 which is equal to z1 z2 z3. First property. Then second property, multiplication is distributive. That is bracket of z1 plus z2 bracket into z3. That is equal to z1 z3 plus z2 into z3. The third property, multiplication is commutative. That is z1 z2 is equal to z2 into z1. Fourth property, there exists a multiplicative identity. That is z dot 1, that is into 1 is equal to z. So fifth property, there exists a multiplicative inverse. Z into z dash is equal to 1. Then division of a complex number. If z1 is equal to x1 plus iy1, which is equal to x1 comma y1, and z2 is equal to x2 plus iy2, which is equal to x2 comma y2, are two complex numbers, then the division of z by z2 is defined as, that is z1 divided by z2, substituting the values of z1 and z2. So the denominator can be written as x2 plus iy2 whole power minus 1, right? Where on the x2 comma y2 whole power minus 1 is multiplicative inverse of x2 comma y2. That is x2 comma y2 is equal to x2 divided by x2 the whole square plus y2 the whole square comma minus y2 divided by x2 the whole square plus y2 the whole square. Then complex conjugate. The complex conjugate are simply conjugate of a complex number. The complex number z is equal to x comma y. It can be written as x plus iy. Is defined as a complex number. Complex conjugate is written as x minus iy. That is, the imaginary part is minus iy. It is denoted by z bar. That is equal to x minus iy. If z1 is equal to x1 comma y1 and z2 is equal to x2 comma y2, then z1 plus z2 is equal to x1 plus x2 comma y1 plus y2. Therefore, z1 plus z2 the whole bar, that which is equal to x1 plus x2 minus I into y1 plus y2, which is equal to x1 minus iy1 plus x2 minus iy2. So z1 plus z2 the whole bar is equal to z1 the whole bar plus z2 the whole bar. That is, the complex conjugate of the sum of the given complex numbers is the sum of their complex conjugate. The operation of taking conjugates is also distributive with respect to subtraction, multiplication and division. Z1 minus Z2 the whole bar is equal to Z1 the whole bar minus Z2 the whole bar. Z1 and Z2 the whole bar is equal to Z1 the whole bar into Z2 the whole bar. Z1 divided by Z2 is equal to Z1 the whole bar divided by Z2, comma Z2 not equal to 0. The conjugate of a real number is the number itself. It may be also be noted that Z plus Z bar is equal to x plus iy plus x minus iy, that is equal to 2x, that is equal to 2r of z. Is the sum of the complex number and its conjugate is real number. Therefore, z minus z bar is equal to x plus iy minus x minus iy, that is equal to 2iy, that is equal to 2 into imaginary z. That is, the difference of a complex number and its conjugate is purely imaginary number. Thank you.